We're going to look at factoring some trinomials. I think you're going to find a little more challenging. So these are going to be trinomials where there is a coefficient on the x squared. So there's a value here, ax squared plus bx plus c. The ones we looked at previously were simply x squared plus bx plus c. We're going to look at two different methods. You can experiment with both and decide which ones you like, which method you prefer. I actually like a combination of two of them. The first one we're going to look at is basically guess and check or trial and check. And what the idea is, we look at the leading coefficient, the 2x squared, and think of what are some different ways 2x squared could factor, such as x times 2x. And then we look at the c value, the constant, and think about ways we could factor -3, -1 and +3, +1 and -3, and then check some combinations of those and see, foil back together, and what we're looking for, do we get the correct middle term, the -5x. So 2x squared really only has a couple possibilities for factoring. We know this leading term is always formed when we're foiling by the first terms. So x and 2x are really the only ways we can multiply by foiling and get to 2x squared. 3 obviously is 1 times 3, but keep in mind this is a -3. So it may be that it's a subtract 1 or a +3, or perhaps it's a +1 and a -3. But we could be combining these slightly differently. It might be x plus 3 and 2x subtract 1, or x subtract 3 and 2x plus 1. And then what we're looking for is, if we FOIL these back together, do we get the correct middle term? Do we get a -5x? So I'm looking at the middle terms, which we find by combining the outside and the inside when we're foiling. So if I FOIL here, x times 2x is my 2x squared. That's covered. X times +3 would be 3x. -1 times 2x is -2x. And of course, -1 times +3 is a -3. Looking at the outside and inside, 3x subtract 2x is not going to give us -5x. So I know this is not the correct factorization. Okay, taking my next combination here, x times 2x is again 2x squared. X times -3 is a -3x. 1 times 2x is plus 2x. And that's going to give me a -x, not a -5x. So again, I know this is not the combination that works. Taking my third guess here, x times 2x is 2x squared. X times -1 would be -1x. 3 times 2x would be plus 6x. -x plus 6x would be a +5x. I'm getting close, but not quite there. Hopefully this next one's correct. So x times 2x again is 2x squared. X times 1 is a plus 1x. -3 times 2x is a -6x. And those combined together do give me the -5x I was hoping to find. And so here is my correct factorization of this trinomial. Let's try another one. Get a little more room here. There we go. Okay, 3x squared and the 4. So I'm ignoring the middle term for now, focusing on my first term. My pen back here, and my last term, the 4. So the ways I can break down the 3x squared might be x and 3x. The way I could break down 4 could either be 1 and 4 or 2 and 2. Everything is a plus here, so I'm pretty sure I'm going to have just pluses in my factorization. So I could try the 2-2 combination. Or a 1-4 combination. Or for 1. A little more readable there. Okay, so again what I'm looking for my middle terms, because my x times 3x is my 3x squared. and my 2 times 2 is my 4. It's the middle term I'm checking. So doing my outside x times 2 would be 2x. My inside 2 times 3x is 6x. That is only 8x, not 13x. So I don't want that combination. Taking my next set here, x times 3x is 3x squared. X times 4 is 4x. 1 times 3x is 3x. Gives me 7x, again too small. I'm not getting the 13x. Taking my next combination here, x times 3x is 3x squared. X times 1 is 1x. 4 times 3x is 12x. And 1x plus 12x is 13x. So there's my correct factorization. Okay, why don't you give this one a try while I pause, and then we'll come back and see if we get the same result. Wow, this one sure had a lot of combinations, didn't it? So here's my list, and a couple hints on how we might be able to shorten the process, because we've got 8 combinations to find. I know my middle term here, the negative x, that's a very small number. So when I start looking at all my listed possible combinations, I am pretty sure that none of these 4 are going to work. Because when I look at the combinations of 14 and 1x, I'm not going to get anything that's going to come up with a negative 1 there. So when you're doing the guessing and checking, trying to do the most likely guesses first for your checks, and then as soon as you find a combination that works, that's it. That's the only answer, and we don't need to bother checking any of the others. So looking at the possible combinations, I think these 2 are the most likely, because the 2x and 3 combination gives me a 6, whereas the 1 and 7 combination gives me a 7, and that's got a good shot at giving me a negative 1 when we add things together. So I just need to check my signs. Here, 2x times negative 3 would be a negative 6x, whereas 1 times 7x would be a plus 7x. That would give me a positive 1x. The second pair here, 2x times positive 3 would be a positive 6x, and negative 1 times 7x is a negative 7x. There's my negative 1x, and there's my correct factorization. Now we do have a second method to try, and you can decide which one you prefer. I like to use the guess and check method, as long as it looks like there won't be too many guesses to make before I start checking. And then I like the second method for a problem like this, where there would be a whole lot of guesses to be checked. So the second method, called the Groupie Method, it's also been called the AC method. And the idea here is to find 2 numbers whose sum is equal to the product of A times C. Find 2 numbers whose product is equal to A times C and whose sum is B. So let's look at this with an example. So this is AX squared plus BX plus C. So my A would be 4, my B would be 17, and my C would be 4. This one would have many, many combinations to check if we were doing the guess and check method. So to use the Groupie method, my A times C is equal to 4 times 4, which is 16, and my B value is equal to 17. So I'm looking for 2 numbers, and for convenience I'm going to call them P and Q. So 2 numbers such that P times Q equals A times C, which in my case A times C is 16, and 2 numbers P and Q that will add up to B, which in my case B is 17. So I'm thinking 1 and 16. 1 times 16 is equal to 16, and 1 plus 16 is equal to 17. Now these are not going to be part of my answer, but what I'm going to do is take these 2 values and expand my problem. So my original problem is 4y squared plus 17y plus 4. And I'm going to expand the b term into p plus q. So I'm going to take this and rewrite it as 4y squared plus 1y plus 16y plus 4. I now have 4 terms, and when we have 4 terms, grouping is the method we like to use. So if I now factor by grouping, I've got my 4y squared plus 1y from my first pair, plus 16y plus 4 for my second pair. Looking at my first pair, I've got a y common to both terms. That leaves behind a 4y plus 1. Looking at my second pair, I have a 4 a 4 common to both terms, and that also leaves behind a 4y plus 1. So I do have the common factor, 4y plus 1. I can factor it out, and that leaves behind the y plus 4. And I've factored my trinomial. And again, we can check. 4y times y is 4y squared. 4y times 4 is 16y. 1 times y is y. And 1 times 4 is 4. So this is equal to, or equivalent to, the original problem. And there's my factored form. So this groupie method, there's a couple extra steps, but what a lot of students like about it is it's a little more straightforward than the guessing and checking. And again, I like to use this method whenever my coefficients on my A or my C are very large, and I know there's going to be a lot of possible combinations to check. Okay, a couple more with the groupie method. So again, on this one, my A times C is 5 times negative 6 is negative 30, and my B value is 13. So I'm looking for two numbers that multiply to negative 30 and add up to 13. So going through with negative 30, I could do 1 and 30. Actually, negative 1 times positive 30, or 1 times a negative 30. Negative 2 times 15, and those add up to 13, don't they? So no reason to go any further. But again, these are not going to be my factors. What I'm going to do is take those two numbers, expand this 13x into negative 2x plus 15x, subtract 6. So I still had the same expression because negative 2x plus 15x is 13x. But now that I've rewritten it as 4 terms, I can use my groupie method. So with my first pair here, I can factor out an x, leaving behind a 5x subtract 2. My second pair, I think a 3 is common. So if I factor out a 3, that also leaves behind a 5x subtract 2. And as long as I've got that common factor, I can take out the common factor, and that leaves behind the x plus 3. And I factored it. How about if you give this one a try? And I'll pause the tape and we can compare answers. All right, did we get the same result? You may have noticed I had an error in there. That should have been a 6t squared subtract 13t plus 6. My A times C was 36. My B value is a negative 13. Looking at the factors at 36, I came across 4 times 9 is 36, and 4 plus 9 is 13. But since I needed a negative 13, I tried negative 4 and negative 9. They still multiply to a positive 36, but add up to a negative 13. So expanding, I then have 6t squared. The negative subtract 13t becomes a subtract 4t, subtract 9t plus 6. Doing my grouping, I took a 2t out of the first pair. And a little tricky here, I took a subtract 3, a negative 3 out of the second pair. That way I ended up with a positive 3t and a subtract 2, because again, I want to have matching factors. If I'd factored out a positive 3, a plus 3, then the signs would be wrong on the second pair. So with the subtract 3, I get the common factor 3t subtract 2, leaving behind 2t subtract 3. Would you like some more examples? You can use either method. Again, this first one, wow, this one's going to be hard. A times C is going to be a negative 72. And my B value is a negative 1. So I'm going to want my factors for my negative 72 to be very close to each other if they're going to add up to a negative 1. So I'm not going to bother checking things like 1 times 72 and 2 times 36. 72 could be, let's see, how about 9 times 8? A positive 9 times a negative 8 would multiply to negative 72 but add up to positive 1. But a negative 9 times a positive 8 does add up to negative 1 and still multiplies to negative 72. So I can take my 6a squared, expand my subtract a to a subtract 9a plus 8a and a subtract 12. Then doing my grouping, the first pair, I'll factor out a 3a. That'll give me 2a subtract 3. Now, since I've got a 2a subtract 3, I'm hoping to get another 2a subtract 3. So coming over here, looks like a 4 is common. And a positive 4 times the 2a will give me the 8a. And 4 times the subtract 3 will give me the subtract 12. And then I do have my common factor. 2a subtract 3, 3a plus 4 for my factored form. I'll pause and you can try the next one here. That one was a challenge, wasn't it? I've got to admit, I pulled out my calculator when I started making my list of factors over here. So when we break down the 196, let me get my pen back here, sorry. I came across the 14 times 14, multiplies to 196, adds up to 28. So expanded the 28xy into 14xy and 14xy. The first pair both had x's, and I also noticed they're both even, so I factored out a 2x, leaving behind 2x plus 7y. The second pair both had y's, and then 7 was common to the 14 and 49, so factored out a 7y, leaving 2x plus 7y also. So this one became 2x plus 7y and 2x plus 7y. Our next one we're going to look at, the next video will cover special products, and this actually is one of the special products. So there was a trick we could have used on this one. But before we go on to that, I want to show you this one, which also has a trick. And what I want you to notice is looking at this particular trinomial, there is a common factor. First thing, if we factor out the greatest common factor of 4, that leaves behind an a squared plus 8a plus 15. This is a much simpler problem to work with than 4a squared plus 32a plus 60. Looking at the a squared and the 15, I think 3 and 5 are going to do the trick. 3 times 5 is 15, and 3 plus 5 is 8.